Hello and welcome to part 2 in the LogicWorks for Windows series. Today it's all about editing, schematic editing. So we'll start off by opening the circuit that we created in part 1. So if we go over to the File menu, we can either use the Open, or we can go down to this area here where LogicWorks lists all of the most recently opened documents. So we'll just click on here, and up pops the circuit from part 1. Now, as we're going to be doing editing, I'll turn off the simulator because it's a little distracting while it's running. So there we go, it's stopped. And what we'll cover first off is deleting line signals and also deleting devices. So the easiest way to delete a signal is just to select it and hit the delete button. And I'll undo that by hitting Control Z. This is true for devices as well. You just click on one, select it, hit delete, and it's gone. And I'll bring it back once again with the Control Z. Now the other way of deleting signals and devices is using the Zap tool, which is up here. And it looks like a lightning bolt. So let's select that, and you'll notice the cursor changes to a lightning bolt. Now the interesting thing here for signals is that you can use the lightning bolt to delete segments of a signal. So for example, if I want to delete this little vertical section, I just click on it and it's gone. And I'll bring it back. There we go. Now the deal is, if you delete a portion of a signal, obviously you'll be creating two signals, and the question becomes which one is going to be named feedback. So let's just go ahead and delete this one here. Now we'll get out of the Zap tool mode by hitting the space bar, and if we go over to this signal here and select it and right click on it, we can do a name and see what it's named. Now it's not named anything, so let's go over to this guy over here and do a name, and you'll see it's called feedback. Now LogicWorks will try and associate the name with the signal segment that's closest to the actual name. Sometimes if it's far enough away, it will create two segments that are unnamed. Okay, there we go. Now of course we can use the Zap tool to delete devices as well, and it behaves pretty much the same as as selecting them and hitting the delete key. We just click on one and it disappears. So we'll bring it back. And let's get out of the Zap mode by hitting the space bar, and let's redraw this segment here and go in and make the label visible, and there it is. We're back to pretty well where we started. Now one of the other things you might want to do is rotate a device. So if you go over here, you select it, right click on it, and then you can rotate right or left. There we go. So I'll just undo all of that, and we're back where we started. So let's make some meaningful changes to this circuit. Let's delete that feedback section once more, and then we're going to go over here and look for an open collector buffer. So we just type in buffer, and the one I want is this buffer here, open collector, and I'll double click on it. Now what about rotating it when it's being dragged from the parts palette? Well, you can use the arrow keys. So if I hit the left arrow key, I'll get it in the opposite direction. There's actually 8 possibilities. There's the 4 major compass points plus 4 cases where it's mirrored around the major axis. So now that I've got that guy pointing the other way, I'll just connect them up to this section here. Click, hit the space bar, and let's say move them over a little bit and connect up the other piece there. There we go. So I don't see feedback anymore, so we'll go and check out the name. There's not one here. I'll bet you it's over here. And what I'm going to do is get rid of it and go to this section and name it feedback. Okay, there we go. Now what I think I'll do now is grab a +5 power source, and there it is right there, and it happens to be oriented in the right direction, so I can just take it and drop it here. And I also want to get a pull-up resistor. Now again, I'll use the keys to rotate it. I'll put it here, and I'll complete the connection right here. And you can tell it's connected with the little red dot. Now we can also move a group of devices. So let's select this guy, and then hold down the shift key and click on the resistor, and then click on the open collector buffer. And now all we need to do is drag it, and the three of them will go together. So there, I've dragged those three over to the right. Now I don't really want to do that, so I'll just Control Z to undo it, and it goes back to where it was. And now up to this point, when we wanted to connect two pins together, we've done it by drawing a signal line between them. There is another way of connecting, and that's connect by name. So let's experiment with that a little bit. We'll just scroll down a bit, and we'll go over here and get ourselves a NOT gate, or an inverter I should say. And we'll place the inverter over to the lower right hand side here. And what we'll do is we'll name that guy. Okay, so let's go and get the name tool. That's him right there. And now we want to come up and click on the end of the pin. If you click on the middle of the pin, you'll be actually creating a pin number. So we'll just click there, and we'll type in D7 and then hit return. Now if I select this, and it's not working. Up to this point, when we wanted to connect two pins together, we would draw a signal between them. But there is another way of connecting things, and that is connection by name. So let's demonstrate that. Let's go over to the part palette and grab ourselves an inverter, and we'll lay it down right here in the lower right hand side. And then we'll go up here and select name tool. And we'll come down here, and we're going to click at the end of the pin, not in the middle of the pin, because that would be for pin numbering. So we click at the end, and then we just type in D7 and hit enter. Now we'll get out of naming mode, and I'll just prove to you that it actually is connected. If we double click on this, you'll notice that it's highlighted this area up here as well. So these two are logically connected. You can also name devices. So let's name this device here. We just click on it and let go. U1. And we've got him named. And we'll click on the end of this guy here, and we'll make a name not D7. And we can either hit enter or left mouse click. Now we can of course move the names after we've created them by doing that or doing this, moving it out a little bit. So it's like anything else, you just click and drag. Okay, let's do a little bit more naming. We'll call this guy over here OSC1, and we'll name this fella here SW1, and we'll move that out to put it right about there. Well, actually maybe a little over the top would be better. And we might name this guy here to be U3 instead of my gate. I think that's all the naming we want to do for now. Okay, I think what we'll do now is move on to attributes. So we can associate attributes with devices or signals, or any component that's on the diagram. So the way we do that is we go over here to, say, the clock we've got down here, and we go attributes. And what we're going to do is give this, let's see, in the value, we're going to put it in there and give it a value of 14.288 megahertz. And we're going to make it visible. So attributes are just a way of documenting your design. Attributes can either be visible or invisible. When you're generating net lists, you can extract invisible attributes. So there is a reason for them. Speaking of random text or miscellaneous text, you can do that with the text tool, and that's just right up here. It looks like an A, so we'll click on that, and then we'll just go and click in an empty area of the design. Right here will do, and we type in maybe the name of this design, random sequencer by C. Jones, capital Jones. Now we just have to click outside that box and hit the space bar, and we're done. So we can move that around if we wish, move it back where it belongs, and that's how you lay down miscellaneous text. Okay, now it's time to go on to busing, or how to create a bus using breakouts. So before we can do that, we have to make some changes to our schematic. So first off, let's pull this guy out a little bit, pull this fellow up, take the zap tool and get rid of this guy and this guy, maybe the label there and the label there, and we'll move this guy over a bit. So let's start with creating a breakout. A new breakout, and we do D0.7, and we do add, and that'll create 8 little breakout pins. So we do OK. We end up with a breakout, but it's facing the wrong way, so we use the arrow key to flip it around, and we just drag it up to the pins and click. Now we'll make a couple more breakouts. This one is D7, D6. I could have done D7 dot dot D6 as well. And we'll take that guy and put him here. And I think we'll create one called D0, just with D0 on it. And we'll put him there. And the last one, we'll just have D7. And we'll put him about there. Okay, the breakouts are laid down. Now, to create a bus, just pull from the bottom of the breakout, join onto this one, click and drag from the top of that one, click and drag from the top of this one. And we've got ourselves a bus with multiple breakouts. Okay, let's put a binary probe on this one. Things are a little close there, so I think I'll just pull this guy down a bit, pull this guy down a bit. Now I want to connect these two up, and I think I'll name the output here back to not D7. I think I have everything just the way I want it. So we might have to go up to simulation and do clear unknowns, because things might have gotten a little confused. And we'll start up the simulator and we'll clear things. And there we go. As you can see, the bus is indeed working, because we can see values here, plus the not D7 is down on the timing window and it's displaying the correct information. So that pretty much wraps up the introduction to busing. I think that's a good place to stop for now. Please join us for part 3. Thank you.